One, two, there you go. So, hello, my dear students in EDA. It's very unfortunate that we have all these natural calamities, but we are still thankful because we are given the chance or an option for me to reach you out through our social media. And thank God I've got my YouTube channel and we have our Facebook account. So there's no reason for us not to finish our syllabus for this semester. Okay, so this is engineering data analysis, second to the last.
To finish our syllabus for this semester. Okay, so this is engineering data analysis, second to the last. To finish our syllabus.
Okay, there is a bit of disturbance there. Okay, so this is the second to the last topic. I still have to introduce to you t-tests, which is the problem solving that I have included in the exam. Okay, so let's get started. I have to share my screen first, okay? All right, so here is my screen. I'm going to discuss it with linear regression and correlation. Sorry. What is this linear regression and correlation? It says here, linear regression gives us a picture of the relationship of two variables that are fitting in a linear equation that is being observed. Okay, example, an equation where there is a relationship between the weather and the academic performance of students. Is there any correlation of the weather and the academic performance? That is what you're going to know or to find out in the equation. Let me just stop the people in the other side. They are making so much noise. All right, so sorry for that. For linear regression, it is like a line equation where you have to establish a line of best fit. This is very common in analytic geometry where you have y is equal to mx, and we know that m in here is our slope of the equation, but you're not going to do like change of y over change of x. There is a particular, a special equation for this, and the b here is the line intercept, okay? That is the intercept. If you say intercept, there could be two intercepts here. It could be an x-intercept or a y-intercept. If this is the graph and you have a line there, for example, this line has an equation y is equal to mx plus b. This is the x-intercept. Okay, this is the x-intercept and this is the y-intercept. Intercept means when the line crosses a particular axis. So for point A, I will label this as point A. All right, so for point A, your x is there, but there's no y because the line exactly traverses your x-axis. And point B, you will have no x, but you only have y, isn't it? Because it's exactly in the y-axis. So this is the x-intercept, and that is the y-intercept. You can have a clue here. When you say intercept, then that would be something like the line crosses a particular axis. Okay, but because in our equation you have y and a b in here, it means that it crosses the y-axis. So the b here is the y-intercept. Do you understand? Do you understand? Okay, I hope that is clear. Let's go to the next one. For the next slide, it is giving us the definition of each variable. I have already given you or defined each of them. So let's go back to the B here. B is the y-intercept, okay, the value of y when x is 0. Let's go back to what I have given you. This is what we are talking about here, okay? When x is 0, y has a value. Now, in the linear regression, you will be getting a relationship of y equal to mx plus b. You're getting the relationship between y and x in here. How are they related to each other? So for example, you have an equation. I didn't save it, but it's okay. For example, you have an equation of y is equal to 1.5x plus 20. Example, this is just it's a random one. What does it mean? If x could be the number of times that you did a good work, number of good works. I'm inculcating values, number of good works. Like your teacher has counted like how many times that you were quiet, how many times that you were helpful, how many times that you were kind, how many times that you were nice, how many times that you know what I mean? Okay. And then y would be the price in money, say in dollars. Wow, it's in dollars, huh? So when you did not do anything good, your x becomes 0. So 1.5 times 0, you will have $20. It means that $20 would be your price for not doing anything. You're just there quiet, sitting at the corner, okay? Nothing is done. You're like robot. You're just seated. Nothing is done there, okay? Then you get a price of 20. But when you have like, you were kind, you were very honest, you were very helpful, like erasing the board even if you're not told to do so, then you have 3 nice works. So what will you do? You will have 1.5 times 3 plus 20, isn't it? So let's just do a simple calculation in here. 1.5 times 3 good works is equal to 4.5 plus 20. You will have $20.5 reward, isn't it? $24.50 reward. So that's what it means. That's how to interpret a line of or a linear regression equation based on the intercepts and based on the relationship of x and y. Did you understand? When x is 0, then you have $20 or y is equal to 20. When x is 2 or any number for that matter, but it cannot go negative for my example because this is value. But when it becomes like sales, a relationship is sales when x would be how much money you have earned within the day. Then of course it could get negative if you don't have any profit, for example, yeah? Or if x is the profit, for example, and y is how much you earn totally in a day, then x could be negative if there's no profit or if there will be more of your purchasing rather than your selling. All right, I hope you have understood that well. Now let's go to an example. Before that, I have here correlation first. Linear regression is related to correlation as well. Correlation is telling you how these two variables could be related to each other. Okay, so you have the x and y relationship. Y is equal to, let's go back to that, mx plus b. So the r here, when r is near, when r is near to, when r is near to 1, like r is equal to 0.99. Oh, by the way, r is always expressed in decimal. When r is equal to 1, of course, they are very strongly correlated. Nonetheless, if your r is positive, I would say, or nearest to 1, of course, strongest is 1, and it reduces as the r decreases in value. But even if it decreases in value for as long as it's positive, there is a positive relation. So we can categorize it as positive relation or correlation. Positive correlation. We can also say a strongly positive correlation. Strongly positive correlation. It can also be moderate. If you can do it like that, categorize your 0.1 up to 1, then of course half of it is 0.5, right? So this one could be a moderate correlation. I would say you can use your own scale as a statistician or the one who is analyzing it. Strongest correlation would be maybe when it gets near 1. Okay. So anyway, that is correlation. Okay. We will have a decimal value for that. Now, for those who are watching, can you please just go to YouTube and then type "you are present"? Okay. Whether you are present or not present, I will be sending this video to your GCs and have a look on it, study it, because we don't have time anymore. By the look of things, we only have like one meeting left, and 2 meetings, I should say, Wednesday, Thursday next week. Inshallah, we will be all good, weather is good and everything. So I am doing this video to anticipate any eventuality, okay? So whether or not there will be something that goes off, then we are still safe because of these videos. Okay. All right. So this is the correlation formula. It's a big, I would say, big numbers and a lot of things that is going on in this formula. Okay. This is the correlation formula, and this is the line of regression. Okay, but there are formula that you're going to use. Good morning to John Gavino. And there are also formula that you're going to use for B or the intercept, and there's a formula that you're going to use for slope. Okay, slope, intercept, and correlation are the only things you're going to do in here. Okay, let's move on to the next slide. Okay, reiterating about the ranges of the correlation. If R is equal to 1, it says here is perfect positive correlation because X increases as Y increases as well. When R is equal to -1, it's perfectly negative correlation that X decreases and Y decreases. Okay, I had a bit of a laugh there because because of the perfect word, perfect negative. And then when R is equal to 0, there's no correlation at all. That's why you have to be very careful with your calculations. So you will get a perfect value of R, positive or negative. Let's move to the next one. All right, so linear regression is used for prediction, focusing, or fitting a line to the data. Correlation is getting the length, the strength and direction of the linear relationship. How strength is it? Is it positively strong? Is it negatively strong? Or there's no relationship at all? That's what it means, okay? So linear regression can predict whatever would be the value in the future, or could also do some how do you call analyzing it backwards, because you can do the line, you can draw the line backwards as well, as far as you want down the line, and you can get some values. I will show you what I'm telling you. Okay, so now we will have an example of the line, the linear regression. So my example here is very simple. Suppose you have the following data set of study hours and exam scores. So your one here is a study hour. If I have 1 hour study, my exam is 60. If I will be studying 2 hours, my exam becomes 65. If I will study 3 hours, my exam score is 70. If my study hours is 4 hours, my exam score is 75. If I study 5 hours, my exam score is 80. So this is just an assumption. Now we have to prove this one through a linear regression. So let's go to, I made this one in Excel, okay? What did I tell you a while ago? Y is equal to mx plus b. We need to know what m is, and the formula of m is this. We need to know b, and the formula of b is this one. Okay. Now, I'll make it wider. Right, so our x's a while ago, they are 1, 2, 3, 4, 5, as you can see here. Okay, I inputted that. I just labeled it x. I labeled it y. I will tell you something about the others. And I just have inputted the values. The 60, like you can see in here, is 60 over there. 1 is to 60, 2 is to 65, 3 is 70, 4 is to 75, and 5 is 80. Very simple. Okay? Now, what is next in here is you are going to get their sums. The sum of x is 15. The sum of y is 350. The sum, why do I have to get for x squared? Let's review or have a look on the formula of m. In the formula of m, you need an n. The n will be the number of cases. How many do we have? Obviously, we have 1, 2, 3, 4, 5 cases only. Okay? So n is 5, as you can see here. Right? This one. And I need a summation of x, y. What does it mean? You multiply the value of x, you multiply x to the value of y. So you have the xy here. Okay? So 1 times 60 is 60, 2 times 65 is 130, 3 times 70 is 210, and so on. Okay, next. You need a summation of x, right? So here is the sum of x. You need a summation of y, and summation of y is here. You need, let me just change that to green. You need a summation of x is squared. So what will you do? You have to square all x's. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. You need a summation of x and square it. These are two different quantities. Okay? This is summation of x squared, and this is summation of x. And after that, square it. So you go back to the table. This is your summation of x, and square it. 15 times 15 is 225. Okay? Right. So that will be m. if I'm going to put it in here, my n is 5. My numerator would be summation of xy minus summation of x times y. You get 250 for that. The denominator will be n times summation of x squared minus summation of x everything squared. You will get 275. Oh, sorry. I pointed at a different one. You get 50, I mean. Okay? Because that is about the slope. Okay? Here. Right. And then for the denominator, you have 275. That is this quantity here. You get 275. And what am I saying? Sorry. No, that is for the b. The numerator is 250. All of this is 250. Get all the values from here. And denominator will be all of this. Okay? So doing so, all students that are watching in FB, please go to YouTube. Okay? My board is there. This is just for you to see that I am teaching actually. All right. So that is for M. What will we do after? Numerator divided by denominator. So numerator divided by denominator, then you must have a slope of 5. That's the one I was trying to say a while ago. So M will be equal to the numerator, 250, divided by 50 is 5. Okay, here. Now we move on to the intercept. Okay, for the intercept, it is summation of y. We have it. Summation of y is here. And then minus m, we know m already because we have calculated a while ago. It's 250 divided by 50. So m will be 5. That will be the one substituted there. And summation of x will just be 15. So the numerator of your intercept, you must get 275. And your denominator is n is 5, so denominator is this. I had detailed it that way, though you can do it by formula, okay? So numerator divided by denominator, 275 divided by 5, this is for your b, the intercept. You get 5, or you get 55 for that, okay? Now, there's also one way, the shortest way to use, to find for the slope. So a slope is 5 and x-intercept is 55. Please say present in YouTube, in the comments section. All right. Let me just pull out my Excel. My Excel is here. I already have calculated a while ago. Look. This is not the question, right? Okay. One way of doing it is you can use the slope formula of Excel. Let me see if I have here, sorry for disturbing. Not this one. No, not this one either. Hang on. I think I don't have the example here. Oh, here. Thank you. Right. So how do we get 5 as the slope? You just do equals and then use the formula slope. Open bracket, and then it should be y, comma, x. That is the syntax. Is slope, you go to y. I hope this is the value. These are the values. Okay, these are the values. So you go to y, And then you have to shade y, giving you a y range. If you look at here, can you see that? Can you see this one? Can you see this one I am pointing at? Can you see that? Okay, I'm pointing at slope here. I'm making round circles here, there. Can you see that? Right. So using that formula, you have slope, you shade, or you have to shade or highlight y. The next range you're going to highlight would be the x. Close it, and now you have this formula. Can you see that on top? Can you see that on top? There. And then press enter. Bang, you go. You have 5. Correct? Another is the intercept formula. You do equals, and then you type intercept as well. Intercept, open bracket. It's the same. It should be the y first. Can you see that formula underneath? Can you see this one? Is a known y's, comma, known x's. You can see from here what you are supposed to shade. So you go to your y and then shade your y column, comma, you go to your x and shade all your x column. Oh, sorry for that. Hey, the argument is not right. So I have to, there, okay? Shade the y first, comma, shade the x after. But be sure there is a comma in between because the formula will not automatically give you the comma. And then press enter, there you go, you have 55. Knowing this two, knowing the slope from the formula y is equal to mx plus b, then you will have y is equal to 5 is the slope, and then a fixed x next to it, plus 55. And this will be your working definition of the line of best fit. Okay? What is this line of best fit? Line of best fit is if you have a lot of points to plot. Okay, for example, these are all the points that you want to plot. You can make one line here, a perfect one line, and that is the line of best fit, okay? By doing the process that we had a while ago, that's too thick. By doing the process that we did a while ago, then you can draw the line of best fit, and this is the line. Okay, because when there's no line, they are all dots, and as if you do not know where to cling your projections, because you must have a line to project. Where are you going to get the relationship of your x and your y if you don't have the line of best fit? So you must have a slope there. But you can see the trend of the dots. The dots are all going up to the right. Yeah? They're all going up to the right. But you must have a line of best fit to define the trend of the dots. Okay. The next thing we have to do is to draw the line of best fit like I have in here. How do you do that? There are some steps that you have to follow in making the line of best fit. Let me just take and, oh, here. I have written it for you. You can have a screenshot so you will have a reference. First is you have to press insert, then select chart. Okay, let's prepare the space for our graph. Okay, I will remove this first, but we will be producing one like this. Okay, press insert. So we press insert, as you can see, and then select chart. The chart is down here. Chart is here. And then select scatter graph. There are scatter graph, yeah, that you can see on screen now. Those that we don't, those without lines and those with lines. And I will select the first one. All right. As you can see, you have 2 dots on the graph. The X and the Y values were not selected yet. So all you need to do is to go to the select data tab on top, press that, and you will have a select data source dialog box. All you need to do is to press the odd, and you will have series name. If you like to put a name in here, like the relationship of X and Y, say you have series name would be hours versus, we'll just have to put versus the score, exam score, yeah? Exam score. That could be a description of what your graph is. I'll put an underscore there because they should be in one way. Okay, hours versus exam score. And then you go to the box for X. What will you do? You have to go to your X values up here. Okay, and then you're going to cover it. All right, covering means you're going to include them in the range. Doing that, after doing that, you can go to Y values this time. So you go to Y column. Again, you have to highlight the Y values from 60 to 80 and then press OK. And press OK again to get out from that. So where is the graph we have formed? Here you go. We only have few, right? Okay. Next, you go to the trend line. You click the trend line. All right, hang on. Click the trend line. Why there are only 3 dots here? Okay, let's do it again. Hang on. The dots did not appear properly. So insert, we have chart, we have the first one, the first dot, and then you go to the plus, you go to the axis, you go here, enter, and then you go to the Y series. You just have to press the plus on top, yeah? Okay, and then, hang on. What happened there? It's not going. Hang on. I want to show this properly. Okay, insert chart. Let's go to more. All right, this is the one. Okay, there you go. And then you have to select you have to select the data. What's that? Insert. I did not press the select data there. Hey. Wait. This is the problem if you're disturbed, yeah? So more scatter graph. Hey, insert this one. And then more scatter. See, it's not working anymore. Scatter. There. Okay, that's the one. Select data. Add. Then you go to the X ones. Then you go to the Y's. And then OK. And then OK. It must be like that. Then plus, you go to the trend line. That's it. Okay? So the trend line should be in dots. I hope you have gotten the procedure very well. Here is the step, okay? Insert, select the chart, select scatter graph, select the data, fill out the X values, fill out the Y values, and then press enter, tick the trend line, and that's it. Okay? The trend line is the line where we have determined its equation. So now it's a very straight line. Why is it a straight line? Because we use the y is equal to mx plus b. But if you're going to plot the other dots, for example, then you can see one like this. So we have to fit them in one straight line. Okay? Now the next thing we have to do is the regression. Okay. The correlation. The correlation. The correlation has got a formula as well, as I have shown you a while back. But there is an Excel formula that you can use. It's just correl, all right? So you do equals CORREL. As you can see, the formula is giving you, returns the correlation coefficient between two set of data. So the correlation would be the word correl using Excel formula, open bracket. You go to the array 1 could be the X range. All right, you have to cover your X values. The X values there, comma, and then the Y values, and then close it, and then enter. Now you get 1 here. As you have seen a while ago, the graph is very straight, so it means it's a strong positive relationship between X and Y. What does it mean? That the number of hours that you're going to spend in studying will definitely give you a higher score in the exam, which is actually the one we are experiencing every time we take an examination. When you get high in the exam, but you did not study, there the question mark, and that is where the suspicion comes in. Yeah? Right, so that's how it is. Let's have an illustration of the other graph as well. What about this one here? The correlation between the one we were doing a while ago, was it this one? The one with 5 and, oh yeah, this is the one. This is the one, yes. But I have another set of data here where you have y is equal to 7.4x plus 2.6. And this is, oh, there's no graphing here. We'll do the graph again. Right, what will you do? You go to insert, and then you go to charts. Yeah, I will pick the first one. There, you must have a blank graph. And then you have to select data. You go to odd. You go to X range. Never mind the series name meantime, because the series name will just appear on the chart title. And then the series of X's, you go to your X in here. There. That is your X. Then you go to Y. Your Y will be this, as you can see what I'm demonstrating on the board, on my whiteboard, and then, or on my screen, and then click OK. And then you click OK again. Hey, what happened? What's that? It's not working. You know, when you do some demonstration, there's a time that it goes funny. Yeah? Okay, let's do another way. More scatter graphs. See? It's not working again. This is something funny with Excel sometimes. Okay, more scatter graphs. See? To create a chart, select the cells. Oh, dear me. Okay, again, insert graph. I hope it will work now. Oh, it's not working again. What's happening? Okay. Anyway, that is the procedure. But I want to make this one perfect for you guys. So insert, yeah. I will click the chart here. Why is it not working? To create a chart, select the cells and contain the data you'd like to use. Okay, why not? Let's just do it. That's what the computer is saying. Okay, the range of data. Now I had put them in. Okay, let's select now. See, if your name is for your rose and God and you'd like to use it, what is this? It's becoming funny. Huh, sometimes I can't understand this computer. Okay, anyway, let's have another one. Oh, I want it perfect, but it's not coming out. So what can I do? Yeah, but the procedure is correct. Insert and you do chart and you select here. There you go. It's not working, is it? Where is it? Where? All right, I think it's working now. Oh no, now I know what's the problem. It's a bit, it's a bit slow. Okay. But where is the one we have selected? The chart is not here. That's funny. I think this is the one. No, look at that. Hey. I hate demonstrations like this, honestly. Chart. What's the point? Yeah, of demonstrating. It's not working now. Look at I think I have pressed a lot. Okay, here. Let's do okay instead. See, it's not coming out now. I think I have pressed a lot. Okay, anyway, you have the procedure on how to do it. It's a funny demonstration. For the last time, give me a chance. All right. Put that in. Oh, there you go. Oh, what's wrong with this demonstration? Gosh. Okay, let's put it up. The values. All right. There, yeah? Next is select data, add, and then go to X, and then select the values. I have another set in here, up to 8. And then you go to Y. There you go. And then okay. And then okay. And there you go. Gosh. Okay, so as you can see here, it's too scattered. Yeah. If we're going to input more, for example, let's change values here. Say my Y here is 10. Look how it changes. See, have you seen that? Right, I will put another here. Say I will put negative 21. Oh, very scattered. Okay, that's not fair. That's not fair, yeah? Let's just put negative 2 there. And then here, let's put, say, 7. And then here, let's put 4. It's very scattered graph. So how are you going to do the line of best fit in here? I'll press my graph and I'll press plus here. Can you see the plus here? This one, the one I'm pointing at. Can you see that? Then press plus there and then go to trend line. There you go. That is the line, okay? That is the line. And what's the relationship of this one? The slope, oh, I did not do it. Okay. This is the one that you're going to find out. It's y equal to mx plus b. You understand? Okay. So that is that is line of best fit. No matter how scattered the points are, then you can put a trend line in your in between the lines, and that will be your point of analysis. Okay. All right then, so I'm going to cut from here and I'm going to give you something to work on. Let's go here and you have a homework down here. Yep, for 50 marks. This is 50 marks, yeah? I want you to draw the line of best fit. Line of best fit. And then you have to interpret results. Okay? So that is your homework, please. You have the equation of y is equal to 4.5x plus 50. You must get this value from your calculation. We will mark this one. We will mark this when we come back next week. Bye for now. Bye. You can message me in your GC if you have some questions. Bye for now.